something that must be very near and dear to your heart, or at least to your addiction, is another open source project that you created that allows for compatibility. And so this is Narwhals. So last year, you described Narwhals as an extremely lightweight compatibility layer between pandas and polars. So what is the problem that you're addressing there with your Narwhals library?
Sure, thanks for asking about it. It still slightly cracks me up that we've got a library called Narwhals that we're actually talking about. It started off as a little weekend project, and I was feeling a bit silly, so I called it after a viral Mr. Weeble song, but now it's being adopted by some people, so I guess we're stuck with the name. Maybe before I go in too deep, just a slight correction. I think this year I described it like that. I only released it back in February. It's a very young project, but it's quickly gaining a bit of traction.
I'm sure you're right. That must be a rare research error.
Well, maybe not a research error, maybe confusion with another similar project. Before Narwhals, I was involved in a group called the DataFrame Consortium, which was trying to make a DataFrame standard, like some DataFrame API that different DataFrame libraries could implement, and then people could write DataFrame agnostic code on top of. It's difficult to get different people to agree, and the stakes here were pretty high, and I just wasn't able to agree with most people there. I found myself disagreeing with most of the participants about nearly everything. I wanted to bring things decidedly towards polars. They wanted things to be not exactly like pandas, but they didn't want things to deviate too much from pandas. They didn't want things to deviate too much from what most people were familiar with, and from what would be difficult for them to implement. So in the end, after having agreed to disagree, I said, well, let's take all of these ideas which the consortium had rejected, and let's package them as its own thing. Let's call it Narwhals, and let's see what happens. And the idea is, it's like what the DataFrame standard was trying to be. So just some API which different backends can implement, and which a library can then use to just define its transformations, to just define its DataFrame logic. And then the user can bring their own data frame, pass their own data frame in, and they can just use it seamlessly, as if that library was written specifically for their data frame. So someone comes along with pandas, they can just use it. Someone else comes along with polars, they can just use it. The pandas user doesn't need to have polars installed, and the polars user doesn't need to have pandas installed. This is what we're aiming to enable. What kind of surprised me was that interest in it happened a lot faster than I was thinking. So within about a month or two, we had Scikit-Lego, which is like a medium-sized library for some extra things which don't quite fit into scikit-learn. And yeah, they decided to adopt it, which, aside from the fact that it's kind of nice as a polars user to be able to use a library without having to convert to pandas, it also made a massive performance difference in some cases. So polars, because of the reasons we described at the beginning of the episode, it really excels at feature engineering. It can do things in parallel, it can do common subplan elimination. And so for the feature engineering functions in Scikit-Lego, doing it directly in polars, as opposed to having to convert to pandas, doing the operation in pandas, and then converting back to polars, it can make... I had one benchmark where I was seeing even a close to 150x speedup. It was really quite massive. So yeah, I was pretty happy with that. And then what made me fall off my seat just a couple of weeks ago was the major visualization library Altair have adopted Narwhals. And so like this, they've made NumPy optional, Pandas optional, PyArrow optional. I think PyArrow might have been optional from the start, but if you were trying to plot a polars library, you were required to have PyArrow installed. Whereas now, you can just pass a polars data frame to Altair, you don't need NumPy, don't need Pandas, don't need PyArrow, and it'll just plot it natively. So for polars users, they just need this very lightweight library, and they can make beautiful, possibly interactive plots. And this is exactly what I was hoping to enable with Narwhals, just a better adoption for polars and other newer data frame libraries at no cost to their existing pandas users.
This Narwhals project, which you only started on a year ago, It sounds like it's
February.
She only started in
less than a year.
right. It already has been picked up by places like Altair. It's already making a big impact. Part of what's so impressive about it is its minimal overhead and its lack of dependencies in its design. So how hard or easy was it to get that level of efficiency? Were there some big technical challenges that you faced while developing?
Sure.
Narwhals?
So on the dependency side, I don't think it's that difficult. I think it's just a matter of willpower. So if you want to keep your library dependency free, I think it's usually not that much of a stretch. In this case, suppose that you're a library which receives a data frame from the user, and you want to know whether it's a pandas data frame. Like, the obvious solution is to try importing pandas, and if that succeeds, you check if it's a pandas data frame. But we can actually do better than that. Because if somebody has passed us a pandas data frame, it means that they must have already imported pandas. So we can just do import sys. We can check all of the libraries that the user has already imported in sys.modules and see if pandas is in there. And if it's not, then obviously this cannot be a pandas data frame. So we don't even need to try importing pandas. So what we're very strict about in Narwhals is we don't import anything. Like this, we don't risk introducing dependencies, and we don't risk slowing things down by forcing people to import things which the object just isn't. So that's part of it. The other part of it is the overhead. That, I think, isn't so immediate because we're translating syntax. The key there is to just have a good mental model of what Polars expressions are. And to me, an expression is just a function from a data frame to a sequence of series. Once you define it that way, then chaining expressions together, chaining these calls, is just a matter of chaining lambda functions one after the other. You just need to be very rigorous about recursively applying this definition everywhere, and it all just kind of happens. There is potential for overhead in the sense that pandas does a lot of things with the index which you don't necessarily want. Pandas is always aligning indices with each other, but Polars doesn't have a notion of an index. So if you want to make pandas' behavior mirror the Polars one with the same API, you need to be careful to avoid automated index realignment. The naive solution to that would be to do reset index all the time, which is in fact what we see in a lot of users' code. Reset index is not a free operation though. So what we do in Narwhals is that the API itself means that when you're comparing columns, they typically are derived from the same data frame, just because of how the expressions API works. So we just do a quick check of whether the index of the left-hand side is the same as the index of the right-hand side. Like, we don't even compare the values. We just check left index is right index. If it is, then we leave it alone. And if it's not, we set the right-hand side's index to be the left-hand side's index. And what I've observed empirically then is that compared to the naive way of writing pandas code, we can often make things a little bit faster, which, although I need to caveat that. So in pandas version 3, copy on write will become the default. This is an optimization. So once that becomes the default, then writing via Narwhals or writing pandas code directly shouldn't make a difference. Before that, I've noticed that Narwhals will often make things a bit faster, unless you're dealing with like a 100-row data frame. If you've got something so small, then the overhead of just the extra Python calls within Narwhals is not... it is going to be detectable. You're going to have an extra 0.5 millisecond there. So if you need to write a reactive web application using data frames, maybe just use the data frame library directly. Don't use Narwhals. For anything more than 100 rows, for anything where 0.5 millisecond of overhead is tolerable, then I'd like to think it's a good solution. And for Polars users especially, that 0.5 millisecond of overhead, compared to the overhead of converting to pandas, it's nothing.
Very cool. Great summary point there. Very cool again. You're getting from me. You have expressed hope for a future where data science becomes data frame agnostic. So could you explain for us what data frame agnosticism is?
Sure, yeah. Well, you very kindly introduced the topic earlier by bringing up Seaborn. Seaborn just takes the data frame and then visualizes it. Like, there's nothing about the logic of the library that should be tied to pandas. So why is it that it only works on pandas? Like, it does accept other data frame libraries, but if it receives anything else, the first thing it does is it converts it to pandas, and then it does everything else. And there's no theoretical reason why that should be the case. Like, I don't know, what does Seaborn do inside? It takes a column, it does a group by, and it finds the sum. Like, I think every data frame library does that. Certainly every data frame library that we're supporting in Narwhals. So I'd like to think that we can aim for a future where libraries such as Seaborn can just define their logic, and then the library can be data frame agnostic. So long as you're either supported by Narwhals or you comply with the Narwhals API, then your library can just slot in there. And the good thing about standards is that they really enable freedom. Because as much as I love open source, I'm not an open source absolutist. And the nice thing about having a standard out there, about having like a Narwhals specification and its API, is that someone can come along with their closed source solution, and we don't need to know about it. Like, as long as their closed source solution respects the Narwhals API, then it'll work seamlessly without them having to ask us for permission to do anything, without them having to open source their library. I prefer it if people open source things, but as I said, I'm not an open source absolutist, and I think this is one thing that a standard specification like the Narwhals one can enable.